Okay, so Dr. Hickey back at you with the third video associated with Unit 2, although the first one was just kind of some business items to be dealt with. The second item was a summary of the material found in Chapter 2, and I want to be quite clear that these little summary lectures that I'm giving are little snippets, just kind of to give you an introduction to what you can expect in that chapter. It is not meant to displace the fact that you need to actually read the chapter in order to be prepared to take the quizzes and exams. Okay, so just keep that in mind. All right, as we're looking at this little image again, a couple things I wanted to redraw your attention to. You know, we have the three tectonic boundaries that are, important in plate tectonics and understanding how the plates have moved around relative to one another over time. We also have, and it's not really showing well here, the way they've exerted this little, this little map, but just here off the edge of the map are the Hawaiian Islands. And of course, hopefully you all know that the Hawaiian Islands are a place where, it's in the middle of a plate, but it's got active volcanism, which is kind of strange because, one of the really cool things about plate tectonics theory is it really gives us a great indication of where we can expect most of the big earthquakes to occur. Okay, if you think of all the big earthquakes that happened this year, Haiti, Chile, Sumatra, Japan, Pakistan, I believe there was one. They're all, Peru was another one not too long ago. Those are all places where there are active tectonic boundaries. Okay, places where the stresses build up for long periods of time, and there's a major release of energy when those plates slip by one another, when the rock system breaks. So it helps explain that. The other thing is, in each, associated with active tectonic boundaries, certain types of active tectonic boundaries, there is volcanism. Okay, so up here in the Pacific Northwest, we have a little plate called the Juan de Fuca that's subducting below North America. We have the Cascade Mountain Range, volcanoes like Mount St. Helens, which has been active fairly recently. Mount Rainier is another one that's up there. Again, a dormant, but still pretty active, or could be active at any given point in time, volcanic system. Okay, you expect it to be there. Okay, we go down through the Andes. There's a lot of active volcanoes down in the Andes. Okay, again, but there's a big subduction zone here, a place we expect them to be, down in Central America. But out here in the middle of a plate, well, there's that other environment called a hotspot, a place where there's a thermal anomaly that exists down within the asthenosphere and coming up through the lithosphere, and when it burns through, it puts out these features, these volcanic features, in places like Hawaii or Yellowstone under our continent. And what's really interesting is if you go and look at where that volcanism is active today in Hawaii, for instance, where Kilauea is erupting, we're forming new rocks. But as you move to the northwest away from that island and go further and further out the chain, the rocks get progressively older. That indicates something about how that plate has moved, again supporting plate tectonics theory. So, all very cool instances of what's going on. Like I said, and we'll learn about different ways in which this gets applied in more detail as we go through more units throughout the text, or throughout this class, excuse me. Okay, so let's move into a few questions. Okay, and I'm going to quickly go through these. Why did people not believe Wegener's idea? Well, one, did he fail to provide a mechanism? He provided a mechanism, but how real was it? Two, he didn't know about earthquake distribution at that time. Well, they had some idea, but they probably didn't know the depth of what we know today. He used fossils and ferns as part of his evidence line. Paleo evidence, but not modern evidence. And four, he used the shelves themselves instead of continental margins. Well, three of those things, expressed different lines of evidence that he used: geology, fossils, the fit of the continents, paleoclimate. Those are all things he used in order to support it. The one thing he lacked was a viable mechanism, so that's where he ran into problems. Okay, let's go to the next question. How can the discovery of coal, excuse me, in a place that's cold and dry like Antarctica be explained? Well, was it that it was formed underwater? Which it is. It's formed in swamps and then carried to Antarctica. Antarctica was once part of a supercontinent, Pangaea, that happened to be located in a warm and humid climate. Think of what I said in the summary video a little while ago. Coal was formed in Antarctica at the same time of ice and glaciers. Not to a large extent. And remnants of dust falling from meteorites. Okay. No, the one answer that makes the most sense here is actually number 2. And you may recall I talked about that when you go back and you put Pangaea back together, things like Africa slide down to where the South Pole is today, and the South Polar region of Antarctica slid up to the tropics, a place where you're going to expect plants to be growing and warm environments and a lot of swamps and coal fields to be developing. So, again, it helps explain what's going on and why we find things where we do. Harry Hess was a person who, back in the 50s, I guess, and early 60s, proposed the hypothesis of seafloor spreading, where at those mid-ocean ridge systems, new material was being, evolved. Okay, so it's where material is welling up or rising from down underneath and actually extruding onto the ocean floor, and the plates were being spread apart. So as you look at these 4 questions, 2 of them talk about sinking material. That has to do with subduction zones and convergence, not with divergence. So you can eliminate 2 and 4 right away. And we talk about rising material in the seafloor. Well, ultimately that material gets extruded onto the seafloor, but that material is actually rising in the mantle, okay? And then when it comes up through the system, ends up spreading laterally to help push and open up the seafloor system, actually creates a little high area there, which helps push the ridges apart. Okay, so one of the things that's introduced into the text is, where, thinking back 2 questions ago, Wegener came apart was the fact that he didn't have a mechanism. Now we have 3 possible mechanisms that are playing roles in the movement of these plates. One is convection, little cells of convective material that's going down inside the mantle. Could be kind of little rollers under a conveyor belt if you think about it that way. The second thing is this ridge push thing, again, because you have that new material being created and pushing things away. And the third thing is something called slab pull. At subduction zones where you get these big slabs of cold rock, denser than the material it's going down into, that's help pulling it down back down into the asthenosphere. I mean, think about what it would be like if you took a steel plate on end, okay, so on the thin end, if you put that steel plate and just set it on top of on top of a block of clay, what's it going to do? Well, just under the weight of that plate, it's because the clay is much more pliable and less dense, that steel plate is actually going to sink down into that clay. Same type of phenomenon. Okay, so another thing that might you'd want to consider what's going on there. Okay, and one last question I'll leave you with: what happens when 2 continental plates collide? The plate moving with the lesser force subducts under the one moving with greater force. The 2 plates will both subduct under each other. Okay. One of the plates, number 3, may be forced under the other slightly, but no subduction takes place. And 4, both plates subduct under each other, which forms deep valleys. Well, a place where continents are colliding and have been colliding over the last few tens of millions of years is where India has collided with Asia. And there, although a little material is being forced down, most of the material is crunching together and being forced up. That's because the continental material, okay, the stuff on the continental plates, is less dense than the stuff underneath it. Okay, so subduction will never occur. So in this case, it's answer number 3. So that gives you some idea of the thought process you want to go through, the types of questions you might be expecting when you go through these quizzes and exam. I'm going to wrap this up for now, and we'll see you again in Unit 3 when we talk about the first of the earth materials, minerals.